Today we're going to demonstrate the installation of an XChange master assembly onto a Creality Ender-5 Pro and some of the things that we want to pay attention to along the way with any installation. This is an example of what you're going to find in the box. This is an XChange master assembly with 3 tool assemblies and in this case a belt and cable. This is an example of a precision screwdriver set that you might have. This will contain everything that's needed to install XChange. You can, of course, also use the tools that came with your 3D printer in most cases. Wire strippers, blue snips are a good idea. In our case, we're going to be changing the linear motion on the X-axis to an MGN12 linear rail. So this is everything that you're going to find in your master assembly kit. We have the machined portions here of the master assembly. Extruder extension cable, fasteners, PCB, mag lever assembly, and some loom and zip ties. So one thing to note is we want to be very careful. I don't have any magnetic objects around right now, but if I did, this magnet would be attached to them. It's super strong, fun to play with, but resist the temptation as when handling this outside of an assembled part, it is actually fragile. So the first thing I'm going to do is attach the master assembly plates together, the M1 and M2 plates, and I want to get my M3 by 10 screws. That's M3 thread, 10 millimeter length. And I'm just going to gently connect these. You do not need to go crazy, don't strip these screws, they just need to be snug. So once you have this adapter assembled, we can insert the mag key, attach the mag lever. The mag lever, when correctly assembled, should sit on the right side, like this. So that the lever should be going to the right when you're looking at it. It's going to ride within those 2 standoffs. So if you assemble it down here, because of the way this locks in, you're not going to be able to get that lever back without risking breaking it. So once we've done that, I'm going to take my magnet. Magnet's going to be a nice interference fit. It's going to fit snugly into the pocket. And I'm going to use my stainless steel flathead screw. And I want to be really careful here, so I start this thread by hand, get the first several in. Now, something that you'll notice about this magnet immediately is that it really likes to grab tools. So we're going to repeat this caution when servicing your machine with the master assembly on it. There's going to be a connector up here, which is obviously quite dangerous if the machine is powered on. So we never advise that you do this while the machine is powered on. Obviously, we're not working on a powered machine right now, so we're fine. So I want to snug this up, make sure that the master is seated correctly against that mag key. I'm sorry, that the mag lever is seated correctly. And you should find that this falls pretty easily. Almost always it'll fall just by gravity. Once this has been assembled, now your installation may vary on the Ender-5 that we're going to install on today. We're going to need access to these 4 holes. This is for mounting on top of our linear rail carriage, our MGN12 carriage. If you are not going to be using these top linear rail mounting holes, then you don't actually need to skip the PCB step. You would, at this time, use your M3 by 5 screws and connect the PCB in the marked holes. So since we're not going to do that, I'm going to set this aside right now. And for us, that's going to complete the master assembly at this point. Now we're going to install the MGN12 linear rail and carriage on the Ender-5 Pro. I've already loosened my carriage, my hot-end carriage here. I'm going to remove the tensioner and the belt from the carriage, remove and set aside. We're going to be replacing this belt because the XChange has a different belt length requirement than the factory Creality Ender-5. And we're going to set our hot end aside for a moment. So be careful when handling your linear rail if it doesn't have like zip ties or plugs on the end, because you don't want to play 1 million bearing pickup. So this is how the rail is going to ride on this particular machine. So it'll be moving like this, and it's going to sit on top. We include, along with the master assembly in the fastener kit, the hardware that's required to mount this. We actually include 5 of these. Only 3 are needed, and some specs actually call for 3, so we're going to use 3 today. So here we've assembled the MGN 12H carriage onto the top of the x-axis. Note that on the Ender-5, we actually did have to move the end stop on the x-axis to allow for this carriage to move, and all we did was actually use one of these M3 T-slot nuts that we did not use on the linear rail installation, and just with a little M3 screw reposition this where we need. So you'll need to adjust this however far you want your X to travel. That's also going to depend sometimes on the tools that you're using and things like that, so your mileage may vary. Now we're going to assemble the master assembly that we put together in the previous step to the MGN carriage using the supplied screws. Don't super torque these. They just, like everything else, need to be snug. You don't want to take the risk of stripping it out. Also make sure that you're using the correct length screws. Using long or too long screws on an MGN carriage can actually cause it to deflect. It can stiffen up the movement, and that's no good. That's if the screws bottom out. So you don't want that. You want to make sure you get at least 2-3 good threads, minimum. So once we have this installed, we're going to move on to installing the PCB. As we don't need to access these screws anymore, it's not going to be covering anything important. And we're going to use the 3 supplied M3x5 screws for the PCB. Okay. And mechanically, the last step that we have is going to be to attach the new belt and put on the belt tensioner.
So a word on belts. We're using new Gates belts. We're going to be replacing the factory belt on this machine due to the longer length that is needed. And we're using a belt with our pre-terminated lower height ferrules, so they're shorter ferrules. That allows the mag lever to clear the ferrule, whereas some factory belts may be too tall, and that also prevents interference with tool plates during engagement and disengagement of a tool and wires and things like that. So if you don't have lower profile ferrules, there are some printable designs, but the easiest way is just to fold the belt end over onto itself, like so. And you can just put a zip tie or 2 on there, and then just slide the loop that you've created into the slot dedicated for the belt ferrules, and then you're good. You don't need any kind of termination. So now we're just going to route this belt back through the way it was originally routed, paying attention to the direction of the teeth. And once we've done this, we'll move on to getting the tensioner installed and tensioning our belt. Next, we'll move on to preparing the wiring harness for the wire-to-board connector on the PCB. Here we just have the basic components from the Mark 8 hot end to the hot end and part cooling fans. And the only thing that we want to make sure of is that we are leaving enough wire on those to correctly route those when we reassemble them on a tool plate. This is going to vary from tool plate to tool plate and machine to machine. In this case, we're leaving about 110 millimeters of length. That is what we've measured for our particular tool that we're setting up that we need to have, and still leaves us enough on the master loom. So we're just going to cut these wires here. And for now, we'll just set these components aside and come back to those later when we're assembling a tool plate PCB. So, something to note out of the different wires that we have here, the red and the white wires, the heater wires and the silicone wires, Yours might look slightly different, but all of them, for the most part, are going to be the most important connections. And we want to make sure that when we're stripping these back, particularly the thermistor wires, we don't want to be very aggressive. In the case of the thermistor wires, it's easy to pull strands of that wire out along with the wire shield, and the same goes for the heater wires, which are also coated in a fiber that can be kind of difficult to cut. So just take your time, make sure that you're not using excessive force. Sometimes you can even pull these off with your fingernail and just clean the strands up with snips.
Now that we've cut our hot end wiring harness and stripped back the wires, a couple of things to note. We are not tinning these wires, we're just twisting them, making sure that we don't have any loose wires sticking out that could potentially short circuit like that. And another thing to note is that you could at this stage use bootlace ferrules. We're not going to. If you are going to use them, it would be advisable only to use them on the higher wattage connections, but in this case we're not using anything that's high enough wattage to where this is necessitated. We're also going to build in proper strain relief when we actually do the assembly to the machine, so that's not something that we need to worry about. One more thing to note, these connectors work best if you unscrew them before you insert a wire. And that just ensures that when it goes in, that articulating jaw gets a nice solid connection the first time. If you were going to use ABL, you can connect your probe wires at this time. There is not a dedicated pinout for this. It's going to be a one-to-one. All of these connectors are. So we will also be publishing some information and instructions on that. But basically, you can connect to your, let's say, BL Touch or any other kind of probe. It's one for one. So if the tool plate is going to have the same connector as this, just make sure that your connectors are oriented the same way on the master as they are the tool plate, and of course make sure that you're correctly connecting them at your main board. Now we've assembled the PCB to the XChange assembly that's mounted on the machine using the supplied M3 by 5mm screws, and we're going to connect our extruder wiring harness to the master assembly. This is that extension harness that's going to connect, in our case, to the factory extruder cable. So I'm just going to connect that like so, and I'll deal with routing this later, and so I'll actually plug that in later as well to the factory cable. So what I want to do is make sure that I'm building in proper strain relief to these cables. As this axis moves over time, these wires are getting strained. That strain is being passed on to this connector. We want to avoid that. So how we avoid that is to just make sure that we have a little bit of slack. It doesn't have to be too much, but we're going to use the tool holes in the PCB and make sure that we correctly route the zip tie here, like so. And it can be a little bit of a tight fit when the linear rail is on. Sometimes if you have a pair of pliers or something, it makes it a little easier. But before you tighten the zip tie, just make sure that the wires have a little bit of strain relief, like this, and then go ahead and tighten them. Now, outside of the scope of this video, but something that is advisable, is to use something like this. This is the the master assembly cover that was designed by Teaching Tech for the XChange. And what this actually allows you to do, it's pretty cool, is route these wires straight up. We also have a version that will allow 180 degree or 45 degree mounts in addition to that. And these files will be made available on Thingiverse and GitHub. Another nice feature about putting this master assembly cover on is that it prevents off-axis connection of tool plates, which is another measure of safety, so that you don't accidentally bridge these pins, or if you could potentially put a tool plate on the wrong way, that you're not going to short something. Once you've reconnected all your wires, you can turn your machine back on. And you'll note that when the screen starts up, you're going to see that the hot end thermistor temperature is reading a negative value. In Marlin, this is normal. This is actually how it's going to work. So the only thing that we don't want to do is run the, try to run any commands to a hot end that isn't there. So if, in this case, for example, I have the extruder connected to the master assembly, I don't want to send any extrude commands, and I don't want to send any hot end, like heating commands or anything like that, because it's going to register thermal runaway and it's going to, have an issue. So if that does happen, of course, just restart the machine. But at this point, if you are getting this screen, this is normal, and you can proceed to tool plate assembly. This is what you can expect to find in your tool plate kit. This is going to be the machine portion of the tool plate itself, a magnet for the tool, PCB, fasteners, injection molded alignment pins, and mag pocket. So the first step is we're going to insert the alignment pins and thread them securely into the tool plate. Make sure that you don't cross thread these. Sometimes because they're injection molded, the threads, might be, have a little bit of flashing or something on them, but just massage them until they thread smoothly. And you can actually do this by hand. You can actually get away without using any tools, although we will have a printed tool that you can use to help. You don't want to over torque these. Just want to make sure that they're sitting flush. Sometimes in the last couple of threads, again, because they're injection molded, that might get a little harder. You can force thread them once you're sure that they have threaded properly. Next, we're going to insert the mag pocket, like so. And that should clip into place. Now the magnet. If you do this into the mag pocket before you insert it into the tool plate, you're going to have a hard time actually getting that in because this is an interference fit. So once that mag pocket is in the tool plate, then we can press the magnet in, and you'll feel it's a very secure fit. We take our flathead screw, 3-screw, and this can be a little tricky because the magnet loves to grab tools, but I like to come in at an angle like this, and then securely fasten the magnet. In no case with any part of this assembly are we really using a lot of torque. And if you feel the magnet should sit ever so slightly down into the mag pocket, and there should just be the tiniest bit of lip around the magnet. That's what you want. Now the PCB assembly. Your mileage may vary on this, depending on whether you're going to run a direct drive extruder, which we actually are. You're not going to put this on yet. But if you're going to be running, something that didn't require those extruder holes or, mounting from the backside, then you could actually put this on. And so one thing to note about the PCB is that there is a sticker here, Kapton tape. Please leave that on. That's just to make sure that, it's an extra layer of safety in addition to the anodize, that there's no short circuiting occurring under those ABL pins. And so let's just say we're going to assemble this now. This is how you would do so. And sometimes it is easier to do the wiring for the tools with the board off of the tool. Just due to the nature of so many different options with XChange, you might find that you need to do these steps in a different order. This is generally how we assemble a blank tool plate. A couple of things to note when engaging and disengaging. I don't want to hold this tool plate like this. So we always want to hold it from the sides. Never from top and bottom, always from the sides. And the reason is because these magnets are quite strong, and as I get these close together, that can actually pose a pinch hazard for my finger. So I want to hold it side to side, and then that will never risk damaging the connector or my finger. Once you've familiarized yourself with the basics of the installation on the tool plate, you can begin to put components on. And so this is going to be beyond the scope of this video, and it's really going to vary so much from machine to machine. And we're really interested in getting your feedback and seeing what your different designs look like. In our case, we've repurposed the hot end components from the Ender-5 Pro. With the Mark 8 hot end, we have a full-size extruder stepper motor with a non-geared extruder and 5015 cooling fan, so we've added that. We have an LED. So really a ton of things that you can do. This is probably one of the bulkier setups that we'll be using in-house, but a couple of things to note. Be really careful when you're handling your tools. You never really want to set these down on the alignment pins like this. We want to treat these alignment pins very delicately. You want to make sure that you're never dropping or bending these pins. These are used for precision alignment, and even though the tips aren't really important, it's just a good practice. Keep when you place tools down, if you don't have a docking mechanism or something for them, keep those pins faced up. Keep them safe. The other thing is, some machines, depending on the placement of your end stops, may require something to help trip that end stop, because when this is assembled, if an end stop is trying to trip, and there used to be a carriage plate here that would do that, and now there is no longer, it's not going to trip. So again, depending on the specific machine, the placement of your end stop, you may need something like this file that we will make available online on our GitHub and Thingiverse to help ensure that end stop is being tripped. Because we haven't made any firmware changes to this machine and we're strictly using XChange mechanically for swaps, we're not doing that in firmware right now. We're going to make sure the machine is powered down and connect our tool plate. And now we can power the machine on. As we can see, the thermistor on the hot end is now reading correctly. It's reading the same temperature as the bed, which is correct because the machine's at idle. And if we attempt to move now, the extruder will move as long as you're above the temperature, and you can perform a quick extrusion test as a last check. This concludes the XChange installation on an Ender-5. We have not modified the firmware and don't actually have to for very basic functionality. However, for changing offsets and things like that, depending on how you do your installation, you may need to modify some values. That's going to be covered generally in some documentation, maybe in some future videos. We will also be publishing firmware files, directories and things of Marlin firmware for popular Creality and similar 3D printers as we develop it. The tool plate assembly and installation is going to be covered in separate documentation and videos, really because there are so many different permutations and so many different tools and hot ends and extruders and ways that you can use this and ABL. There's too many for us to cover. As the community begins to use this and creates files and it asks us for to create adapters and things like that, we will be sharing that in our GitHub and as well on our knowledge base on our website. And if you have any input, if you've designed any files, if you find that you do something differently that that you think is better than the way that we're advising, let us know. This is still very early in terms of documentation. It's very early in development, and so we'd really love to hear feedback now that we're getting the XChange out there and into more people's hands. If you have any questions, please reach out to us directly, and we can offer general support. That is support@printermods.com. You can also go to printermods.com Monday through Friday, 10 a.m. to 5 p.m. Eastern Time, and chat with us. Please note that support for individual, specific installation requests for different machines may be lacking because we simply don't have every machine in-house. So what we've tried to do here is use a common machine where we have to make a couple of changes like end stop positions and things like that to show you what to expect on your average machine of this kind. there's going to be, when you talk about more complicated geometries, you're going to need belt adapters, like, for example, Core XY is going to require, a printable belt adapter. Depending on the type of Core XY, it may be different than others. We kind of have to rely on the community to develop these along with us, as we don't have all of these machines in-house and the ability to test them. So please direct questions, inquiries, feedback to us, and we will always do our best to help it. If we don't have a solution that we've directly developed for what you need, we'll try to point you to something that's been shared with us by other members of the community. Thank you guys so much.